right, in this lesson we're going to go over the area of regular polygons. This is not in your book, so take out some notes and we're going to talk about what a regular polygon is. A regular polygon is just a shape where all of the sides are equal and all of the angles are equal. Like a square is a regular polygon, it has 4 sides. This is a regular pentagon, all of these sides are all going to be the same, and all of the angles are all going to be the same as well. This irregular pentagon is not regular because all the sides are different. And so we're going to try and figure out, how do we figure the area of regular shapes? So in order to determine that, we are going to discuss a couple of new vocabulary words. The way that this is presented here is it talks about a shape that has a circle on the outside. It's called the circumcircle. We've done that before. And then a circle on the inside is the incircle. Now, as we also have discussed, the more sides that a shape has, the more circular it becomes. Of course, we can't have a circle because that had infinite sides, but the more sides that we have, the more the incircle becomes the circumcircle. And they get closer to each other because the shape is more circular. So there are two things we have here. The distance from the center to the circumcircle is going to be the radius, and the distance to the incircle, that is called the apothem. Now the apothem is actually what we care about here. This is called a side length, but you know that that's just one of the distances of our shape. So how are we going to use this information to help us find the area? Well, the way that we're going to find the area of any regular shape is we're going to break it into triangles. We're going to break it into triangles such that each triangle here is going to be the same, and then I'm going to do a little bit of work here on the side. So I'm going to summarize basically what all this is saying here. The area of any triangle is going to be 1/2 base times height. In this case, we have here our apothem and our side. So we can write that as the area equals 1/2 of the side times the apothem. Then we can say if we find the area of this triangle, we just could take the area of that, multiply it by how many triangles we have, and then we will get the area of the entire shape. So we'll take this information and we're going to multiply that by the number of sides. So we'll say n equals number of sides. If we were to look at what is the perimeter of our shape, all we need to do is we could take our side, multiply it, or side length, multiply it by how many sides we have, and we will have our perimeter. So I'm going to call this perimeter equals the n, which is the number of sides, times the area of each side. So I'll just say area, times the length of the side. So the side length. Notice that in this equation here, we have a side length, because I said 1/2 of the side length times the apothem, and we have an n, which is equal to the perimeter. So which means we could summarize our area of our regular polygon as the perimeter times the apothem divided by 2. Or 1/2 perimeter times apothem. Or area, I don't really have a formula that's written for this. P times, you can't use A because A is area, so apothem, 1/2 of the perimeter times the apothem divided, or 1/2 of the perimeter times the apothem. Or perimeter times apothem divided by 2. So how are we going to use that? Let's go ahead and look at an example here. I want to find the area of this regular hexagon. So I'm going to say the area is equal to the perimeter times apothem divided by 2. So we need to figure out what the perimeter is. We have the apothem. The apothem is 10√3. So let's go ahead and use our trigonometry in order to figure some things out here. We have a 6-sided shape. We want to find out some angles. How many degrees are in a circle? 360. We have 6 triangles here, so we're going to divide this by 6. And that gives us 60 degrees. So that means that one of these is 60 degrees. In fact, all of these are 60 degrees, but that doesn't matter. We're talking about this triangle here. Notice it's cut down the middle. Half of 60 is going to be 30. And since this is a right triangle, then that tells us we have a 30, 60, 90 triangle. And if you remember our shapes, our 30, 60, 90 triangle is special. There is a relationship between the height here, the length of our hypotenuse, and then this side. However, I'm not going to use any of that. We're just going to use our sine, cosine, tangent in order to figure out this length. Because if I find this length, I'm going to multiply by 2, and I'll find out this length. Then I could take this is going to be our side, and we can use our area formula. So I want to figure out what x is. So I'm going to say, what trigonometric ratio relates 30, the opposite, and the adjacent? Hopefully you said tangent. So the tangent of 30, I could also do the tangent of 60, but I'm just going to do the 30 here. So the tangent of 30 is opposite, which is x, equal x over 10 root 3. So if we type in the tangent of 30 into our calculators, making sure that our calculator is in degree mode, then we can do the tangent of 30, and we will get 0.57735. I'm going to do as many decimals as I can because I want to be as accurate as possible. I'm going to take that number, and I'm going to multiply it by 10 root 3. And I end up getting 10. So x is 10. That means that OG is 20. So we're going to use our formula here to plug in the information we have. The perimeter is going to be 20 times 1, 2, 3, 4, 5, 6. So area of our figure is 20 times 6 times our apothem, which is 10 root 3, divided by 2. So we'll just do 20 and 2 is going to cancel out. So this is 10. 10 times 10 is 100, and 100 times 6 is 600. So 600 root 3 units squared. If you rounded this number here, you won't exactly get 10. So I'm not really that stressed about how off you are. It's not that big of a deal. All right, let's do another example. In your homework, sometimes they're going to give you the side lengths and sometimes they're not. I'm going to show how easy this is if they do give you the side lengths, because all you need to do is the area is equal to the perimeter times apothem divided by 2. Our perimeter is just going to be how many sides there are times 12. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sides. So 8 times 12, that's going to be our perimeter. Our apothem is 14.5. And then we just divide this by 2. So 8 times 12 times 14.5 divided by 2. We get 696 units squared. Now, what if they don't give you that, like the example on the above? So let's pretend that this 7.5 doesn't exist. How could we find 7.5? Well, we're just going to draw a triangle. And we're going to figure out how many degrees is this. So how many sides do we have? We have 5 sides. So I'm going to take 360. I'm going to divide that by 5. And we end up getting 72. I'm going to take that number and divide it by 2 because this is 72. So we're going to divide that by 2, and that makes 36. So I want to figure out what this length is, so we'll use tangent once again. So the tangent of 36 degrees is opposite over adjacent, which is 5.1. So I'm going to do the tangent of 36 times 5.1, and that will give us 3.705 equals x. Notice that in order to find out our side length, I will multiply that number by 2, and I get 7.41. Now, this number is not 7.5. So that means that this is a rounded answer, which means that if you use this side length, your answer is going to be a little bit off. This answer right here, 7.41, since we use trigonometry, is going to be way more accurate. So our area is going to be 1/2 times our perimeter, which is 7.41, times how many sides we have. We have 5 sides, times 5.1. So 7.41 times 5 times 5.1 divided by 2. I got 94.47 units squared. So what I would like you to do is go ahead and attempt these two problems. So pause the video, attempt these two problems, and I will see you in just a sec. All right, great. Let's see how you did. There's number 5 and number 6. If you have any questions, I will see you tomorrow. Let me know what you have, and your assignment is going to be uploaded on our website. Just these 6 problems. Notice that all of these 5 do not have a side length, so you need to find them yourself. This one does. This one is much easier. You can just use the formula, but you'll have to use tangent for all of these 5 problems. Okay. I will see you later.